I want to briefly discuss about basis functions in finite elements. As always in the FEM formulation, we start with this equation. The solution is approximated by a set of basis functions psi. You see from the sum here, the larger the n, the more accurate the approximation is. Expressing the basis functions is more conveniently done in a local coordinate system. Suppose ρ is a local coordinate, then this simply becomes u of ρ in terms of psi of ρ. To come up with these basis functions, which we now think as interpolation functions that serve the purpose of approximation, we start by thinking about the number of functions needed to approximate a linear function, i.e. if u of x is just linear. We are familiar with a linear function, y equals to mx plus c, or in this context, I simply rewrite with different notations in terms of the field variable u of x. And so here we have two constants to play with, which means in the relation to the approximation function, we have two coefficients a1 and a2. This should make us think we only need two functions like here. Now these two functions per a subdomain match with what we see earlier in my previous lecture of the formulation. Remember, these two functions are part of hat functions. So we write u bar as this. It's just another way of looking at the same thing here, where now I'm showing you from the perspective of interpolation functions. With ρ0 from -1 to +1, where 0 is at the origin, you can see the symmetry of these two functions with respect to the middle axis, so that you can write the linear functions as this. So we have psi1 equals to 1 minus ρ over 2, and psi2 equals to 1 plus ρ over 2. I want to show you how we transform a linear function in global coordinate x into the same functions in the local coordinate ρ. Say you have a function like this from 0 to 1. So u of x is 10x. Now how do we do this in the local coordinate? If you look at the setup here, so we start with the standard expression of u bar with these basis functions. So we set at the endpoint ρ -1, where the value is 0, so that automatically you can see that a1 must be 0. Now doing for the other end at ρ equals to 1, so just plug in the number there and the values there, you must get a2 to be 10. So we have this simply as u bar equals to 0 times psi1 plus 10 psi2. In terms of ρ, we have just simply, if you simplify the expression, 5 times 1 plus ρ. So you see here that the u bar in this case is just being expressed by psi2. Now for the second example, when you work with the same steps as before, that is matching the values of u bar at both ends, you have this final expression. From this example, you see that the unknowns a1 and a2 are like the heights of the hat functions. if we look at this as part of head functions over the whole domain. Now, what if you have a nonlinear function to approximate? This is where you have error of approximation. And a large aspect of numerical methods like the FEM is to characterize and minimize this error. So you see in this case, it matches the BC, and at certain intersection here where you have exact solutions, but most of the locations are with error. By intuition, disregarding the nonlinearity of the function over the whole domain like this, within subdomains we can have a reasonably good approximation even with linear approximation. So as you can see here, the more subdomains you create, the less error you get in the approximation. So that's it. Thank you.